Good day everyone, this is Mom G. Hansel T. Mondigo and welcome to my lecture video. In this video, I am going to discuss to you the proving in special right triangle theorem, specifically in 45-degree, 45-degree, and 90-degree triangle theorem. Or also, this is what we call the isosceles right triangle theorem. So considering this figure, we have the triangle LAB is an isosceles right triangle at angle A. This means that the angle L is 45 or measures 45 degree, also with the angle B which have 45 degree. So let's prove that our hypotenuse is equal to our AB square root of 2 is equal to LA square root of 2. Now let's proceed to my second slide. We have here 45-degree, 45-degree, 90-degree triangle theorem or isosceles right triangle. In this theorem, it states that in an isosceles right triangle, the length of the hypotenuse is equal to the product of the legs of the square root of 2. So it forms, or in symbolic form, if a length of a side is x, then the measurement of hypotenuse is x square root of 2. Again, we have here the given. The triangle LAB is an isosceles right triangle at angle A. So let's prove that LB is equal to AB square root of 2 equal to LA square root of 2. So considering again this figure, here the line segment LB is our hypotenuse and our legs which is LA is our LA square root of 2 and our AB is AB square root of 2. We have here the next slide. So since this is still a theorem, let's prove if this is true in all right triangle or in all isosceles right triangle. So first, we have the statement. So this is not a given. Triangle LAB is an isosceles right triangle at angle A. So in step number 2, we have our line segment LB is the hypotenuse. So this is in the definition of the hypotenuse because as you can observe, this is a right triangle and the LB is the hypotenuse. Third, so since this is a right triangle, we could create a Pythagorean theorem formula. So we have here the LB squared, so the hypotenuse is equals to LA squared, which is our leg, plus AB squared, which is also our legs. So through the definition of the isosceles triangle, we consider, or we have here, LA is equals to LB. So this means that an isosceles triangle has an equal side. So we have here LA is just equal to our AB. So we have here LA is equals to AB. Now, through substitution property, since we know that our LA is just equal to our AB, then we could also say that using the Pythagorean theorem formula, we have LB squared is equals to AB squared, which is also known as LA plus AB squared plus AB squared. So we have here, still this is the same Pythagorean theorem formula to our step number 3. Next, we have here the LB squared is equals to AB squared. So by the addition of polynomials, we could simply get the sum of our AB squared plus AB squared. So we could simply add this AB squared plus AB squared, then we have 2AB squared. Next, we have here LB is equals to square root of 2 times AB squared. So using the square root property. So if you are going to, we are going to find the LB here. So to get the LB, we should use the square root to cancel these two. So if you're going to get the square root on the right side, then you do the same on the left side. So we have here LB is equals to square root of 2 times AB squared. Next, we have here the LB is equals to AB square root of 2. It is because when you squared AB squared, so you just simply cancel out this squared and this square root. So that is according to the law of radicals, where now we have LB is equals AB square root of 2. In here, we now know that our LB is just equal to our AB square root of 2. So, at last one is we have LB is equals to LA square root of 2. Since we know that our LA and our AB is just equal, then we could simply substitute LA or AB as LA. So, in this step number 8 and 9, we know that, or we have proved that our LB is equals to AB square root of 2 equals to LA square root of 2. So we have here a given triangle LAB is an isosceles right triangle at angle A. So here, since we have proved that the theorem is true in all isosceles right triangle, then here we have the representation of the isosceles right triangle where LA is x, AB is x, and our hypotenuse or our LB is x square root of 2. So in the next slide, I will give a example. So we have here the triangle LAB is an isosceles right triangle at angle A. Solve for x and y. Given this figure, triangle LAB, and also this statement says that if AB is equals to 8, find LA is equals to x and LB is equals to y. Since we have proved that our theorem is correct in all isosceles right triangle, then we know that LB is equals to AB square root of 2 equals to LA square root of 2. Here, to find the value of our x, since our AB is equals to 8 and we know that AB is just equal to our LA, we could simply substitute or use 8 this as our value of our x. So we have now, since AB is equals to 8, then LA is equals to 8. Now we get the value of our x, which is 8. Here, to find the value of our y, according to our theorem that our hypotenuse is just equal to our x square root of 2, then let's simply substitute the value of our x, which we found here in finding your x. So we have here y is equals 8 square root of 2. Now, we found that it is very easy to find the value of our x and y. If you could only remember the theorem, the isosceles right triangle theorem, or what we call the 45 degree, and 90 degree. I guess you know now how to solve or to get the value of our x and y using this theorem. So, this is Ma'am Gia Hanzal Mundigo. Thank you for watching.